evening. Regarding the Weka installation, which is a very simple platform to practice your data science and machine learning modeling, you can actually get it downloaded online easily. Just type Weka in Google. It takes you to the Waikato University environment website, that the owner of that software, and then you are going to see several versions. Usually, you have the most updated version there, depending on your machine. You can always install any version, it will work. But if your machine is new and latest, then it's better to go for newer versions. So because it has more newer facility and some other stuff. Another thing to take note there is going to be 64-bit machine and also the 32-bit machine. Of course, they are phasing out gradually the 32-bit, but they are still producing it. In case anybody still hold on to the 32-bit version of the systems. So we just download the appropriate version. Are you on Linux operating system? Are you on Mac? Are you on Windows? So I know majority of people are on Windows these days. So just download the appropriate version. If you face any other issue, Prof, you can always chat us. So we provide the link to a direct version that you may actually install. And you can have multiple versions on your machine. So that's another thing. You only open the one you want to use. So some are heavier. The newer version may be heavy. So if you don't have huge memory, then you may go for lower versions, depending on the problem. Okay, that's about the Weka.
Thank you.
Yeah, you're welcome.
Yeah. Yes, regarding my question, when you were explaining that if a column contains several missing values, and one may choose the option of deleting that column. Majorly in in econometrics, the column contains our variables, meaning that we are deleting the entire variable and we may go for option of replacing that variable with another variable entirely, or looking at other sources of data that can replace the actual one that we have.
Yeah. Thank you very much, Prof. As usual, that's very insightful question comparing with the econometric. You are right. So there's the school of thought that believes every variable carries an information. So when you delete a variable, you're actually deleting important information. Yes. However, the idea of machine learning is that it's not how much, but how well. Sometimes you may have 15 variables. Yes, they carry information, but what the actually dependent variable we want to estimate, we want to predict, not all of them are going to work to contribute to it. You get the point now. So machine learning has that capability to select the best of variables out there that can combine together to get you the better result. In fact, there's a problem we call cost of dimensionality. This is what the problem we run into. When you have, the more the number of features you have, we call it cost of dimensionality. Dimensionality. See, it's a simple problem. If you have X1, X2, you have only 2 features. It is expected that you need, for 2 features, you need like 10 raised to the power 2 samples, which is like 100. With 100 samples, you may get better result or good result. With X1, you need 10 raised to the power 1. That is only 10 samples may work for you. So as you add more features, X3, you need 10 raised to the power 3. That is 1,000. If you have X4, you have 4 features. That is 10 raised to the power 4. That is 10,000. You can see it's an exponential growth. One feature is adding an exponential need of more samples. And we know that our samples, they are limited in reality. In fact, a client may send to you 7 features, X1 up X7, and they send to you 300 samples only. And for X raised to the power 7, you are expecting to have like maybe millions of data. But here you have only 300 samples. What do? This is what we call cost of dimensionality. The number of samples needed to get a reasonable result with every increment in the number of features is an exponential growth. An exponential growth is not solvable. It means we have to go by an optimization. which is feature selection. So we bring all these features together, and then we select the ones that are more appropriate to them. It's okay, 1 plus, use 1 with the Y, you have your output there, estimate it. What did you get? Combine X2 and X3, check it. X3 and X4, check it. We find out that when we combine X1 and X3, we are getting the best result. So we go for X1 and X3. Even though there are other information in X2, X4, they are not producing the result we wanted, so we kick them out. That's it, because what we are interested in is we want to estimate something correctly. We want to predict when there's going to be the next hurricane. We are not interested in the number of features. We are more interested in the accuracy of the model. So this is where the big difference actually lies. So if we remove features, get better result. We need to do it because of the cost of dimensionality. That is when we are not having missing value. When you are having missing value, it's added to more trouble. It means if we input the value, we are risking inputting wrong or fake values. And with fake values, it may take us away from the correct insight that we want to have from the data, which is dangerous to make the business compete correctly or appropriately with their competitors. I hope that clarifies, Prof.
Okay, thank you, Prof. If you need to do something similar, what you have explained is parsimony. You use the word parsimony.
Okay. Okay.
Yes. If you have too many, features, okay, you have to test for multicollinearity to drop those ones that are strongly correlated among them, so that to avoid some, the parameters can behave better. Okay, so the manageable size that the model can accommodate, and that is what is called parsimony in econometrics. But coming to the environment of machine learning, I think I've learned a lot, and it has been giving me, less stress in arriving at some results, because once I do feature selection, and those variables, you call it samples, so features, right? Okay, those features that are selected, when I take them to econometric package, they become automatically statistically significant.
That's interesting. Okay. Thank you for that. So that's a good feedback. So it means you'll be taking the benefit of machine learning, being able to select the correct features will make your life easy rather than having all the features, both the ones that are needed and the ones that are not needed. Thank you very much, Prof. Thank you.
Yeah, thank you, man.
Yeah, thank you very much. So I believe 1 or 2 people are raising hand. Mr. Olatunde Akinrolabo, you have the floor.
Yes, sir. Good morning, sir.
Good morning.
Professor, thank you very much. Yes, sir. Thank you very for the wonderful things and stuff. Yes, sir. So, okay, sir. I just want some clarification about the later part of the session about missing data. Okay. And just as you said, sir, that there are some algorithms that can handle missing data themselves without trial and error, such as decision tree and random forest. So I would like to ask, sir, which one might give the better performance if we try to, let's say we are using decision tree, for example, and we know that it can handle missing data. Should we leave it to handle the missing data itself? Would it be preferable for the algorithm to handle the missing data itself, or during our data preprocessing, during our preparation, we fill in the data set, the missing data ourselves? Which one would give the better performance?
Okay, thank you very much for that question. Yeah, well, the way to approach it is always remember that statement. That thing I wrote often. I usually write it out from here repeatedly, and that is let the data speak. See, there's no method that can always guarantee correct result. You have to check it out. So when you have your data set, The best is to make sure you work with original data as much as possible. When I say original data, close to the one from the source with missing values. So when you put into decision tree, let's see the outcome decision tree is bringing out. Decision tree, after all the optimization, is giving you maybe maximum of 55% accuracy or 70% accuracy. And you still felt that, no, this is low. Then in that case, then try other method. K-nearest neighbor is not going to run because there is a missing value. So you have to treat the missing value. How do I treat it? Go back and get the data correctly. If not possible, then delete some rows or some rows or columns that have more missing value so that you have those without missing value. Because it's always good to deal with lack of the one without missing value. But if it is not possible, then you have to do the imputation. Start with the mean value. Very easy to do, easily. Or the mode, instead of going for using another algorithm to do the estimation. That's going to take a lot of time. We start from simple to complicated method. This is the idea. So there's nothing that can guarantee that decision tree or random forest is going to get you better result. So we have to run that data on those algorithms, get the result. If the result is okay, that is fine. One of the advantages of decision tree is easier for you to explain the result to your client. Your client can easily understand what is going on because it's just like a tree. It's an inverted tree, whereby you see what is going on physically there. And this is my tree. I start from this node. It's still a pass or fail. You go here. It's still not failing or passing. You keep partitioning it as you go down the tree. So you can easily explain what is going on to your client. With some clients want you to be able to explain what I've done to them. In that case, and it worked fine. You are getting good result, 99% or 100% accuracy. Confusion matrices, all the performance measures are doing fine. That is good, great. Then you are done with your work. You report it. However, in some cases, maybe due to research need, literature review, you may have to compare your work with earlier work. In that case, earlier models used may not support missing value. So you have to treat the missing value for you to be able to compare your results. So these are some of the reasons why you may have to go for missing value treatment. That's why I said, I don't want to say it's compulsory, but it's almost compulsory because majority of machine learning algorithm will not work without treating the missing value, except for decision tree family that may also work even with missing value. So if it is working for decision tree and random forest and their family of you building ensemble using decision tree, and then you are able to get the result you needed, that's fine. Excellent. Because in real life, it's always normal to have missing value in real life. Either somebody is forgetting to enter something, either something malfunction. So if we can have an algorithm that can deal with the missing value while giving us better result, it's better. But in most cases, if decision tree does not understand the underlying relationship in that data you are modeling, then you may need other algorithms to work on them to be able to get your better result. In that case, we may not be able to run away from missing value treatment. So always remember, let the data speak. There's no algorithm that can guarantee that. If somebody tells you that the best algorithm is this, that person doesn't understand the principle of machine learning very well, or he missed something, or he forgot that no algorithm is better in all situations. The one may work in one situation, bring another data, the best one there may not perform because there is some underlying information within the data set that machine learning algorithm is trying to bring out. So you have to keep looking for the one that will understand the underlying insight within your data. I hope that clarifies your point, Mr. Akinlora. Thank you.
Very, very well, Prof. Thank you very much. I have clarity of what I need now.
All right. So we're going to the last.
Hello, Prof.
Okay.
Hello, sir. I think there's a note on that question if I actually understood what the questioner was saying.
Okay.
What you explained, ab initio, is that for the treatment of missing value, we have methods that we could use.
Yeah.
The first one, you said that we go back to the source. then probably some of other ones. But what the questioner was saying is that can like k-nearest neighbor or random forest, can it handle the process without the treatment of the missing value? So that in the course of developing the model, that KNN or a random forest will take care of the missing value without its treatment from ab initio before developing the model. I'm not sure if my question is clear.
Yeah, it's correct. Yeah, I answered his question. He understood that. I think you are the one that you missed something there.
Yes, exactly.
K-nearest neighbor. I think you got the point, Mr. Kinolalabu.
Yes,
I answered your question. Am I right?
Yes, sir. Yes, sir, perfectly.
Yeah,
I think you were the one missing.
Yeah. K-nearest neighbor is not part of those that can undo missing value automatically. Decision tree has that capability to work even with the presence of missing value. The problem now is that we cannot guarantee that it's going to work for all problems. You may be lucky that your data set is working fine, 99% accuracy on this with missing value in decision tree. But you bring another data set with missing value, is giving you 20% accuracy. There's no way you can go with that. So you have to look for other algorithms. Unfortunately, you have to do missing value treatment. That's why we can't run away from it. That's why I say it's almost compulsory, but then you can still do it. You can still do some modeling using decision tree and the family of decision tree without doing missing value. Because missing value treatment is very challenging. If you don't treat it well, you'll be dealing with fake data finally, because you have replaced so much value with main, mode, median that your data is far from being the original data. We always want to work with the original data as much as possible. So this is the idea. So I hope that clarifies for everybody. Thank you very much, the coordinator. Yeah. There's a question online. Good morning. What software package do I need to download and install on my laptop? Okay, you can download. Yeah, you can download Weka, W-E-K-A. You can see there. Just search it, download. It's a very popular free software and very powerful. You can do a lot of things there. So especially for those people who don't know programming, if you know programming, then you have Python, MATLAB, R. There's so many programming languages also for machine learning. However, there's a difference between machine learning and programming. So if you want to learn machine learning for your own area of specialization, especially people who are not from computer science background, you don't need to bother yourself about programming. Know the concept first, and then use this no coding approach so that you can solve your problem. Either you want to do research, you want to solve your problem in your company, whatever you need to use it for. Later, programming is another thing entirely. You can learn it if you are interested in that. But without programming, you can still do your machine learning and AI problem modeling. And the question closer to that is that Weka be used to process image-based data such as breast cancer? Yes. You can virtually do whatever you have deep learning in Weka also. You can virtually do whatever you can do in other platforms in Weka. So it can process image. You just need to have, the challenge with image processing is you need a lot of memory. So you may quickly run out of memory and then say out of space. But if you have very powerful laptop, of course, we know that laptop is not for experiment, ideally. I call it an abuse of laptop. So by using it for too much experiment, we are supposed to have a desktop, or we can subscribe to system that whereby you can be able to use a very powerful machine remotely from your own machine where applicable. However, I can confirm to you that Weka can actually handle image data. Yeah. So I think those are the questions we have for today. Somebody was raising up one. I think she's the one, Dr. Sefinat Muhammad. So I think that your question has been answered. I hope so. I think that's what we have for today. Thank you all for listening and for attending. We look forward to again another edition next week by the grace of Almighty God. So thank you all. I wish you the best.